So hello again. My name is Jan Grolich, and I will talk about distribution of Qt apps to other platforms. So first, let's start with some introduction. So I work for Red Hat, where I'm part of the desktop team, and my responsibilities there are to take care of Qt and KDE packages in RHEL. And besides that, I also try to include Red Hat's emerging technologies, such as Flatpak or Pipewire with KDE or Qt. And I'm also part of Fedora KDE SIG, where I occasionally package Qt and KDE. And I'm also a big fan of KDE and user and developer there. For example, I maintain the Plasma Network Management applet, so I contribute there as well. So about this presentation, so why am I giving this talk? Like a year ago, I took over maintainership of Fedora Media Writer. If you don't know Fedora Media Writer, that's a tool we provide to users. It allows them to easily download any Fedora variant and write the images to their USB drives. It has a nice UI and it's available on all platforms. And before that, I had zero experience building Qt applications on Mac and Windows. So I had to learn how to do that. The previous maintainer already had some build scripts written, but I introduced some new dependencies and I rewrote the application to CMake. So I had to learn everything, how to do that and update all the build scripts to include my new dependencies and to accommodate CMake changes and things like that. And it was not a really easy process to learn everything. It sometimes may get complicated. So I decided to give this talk. So I will mention tools we use to distribute Fedora Media Writer and to build it on Windows and macOS. I will give you some examples of CMake usage because that's something I learned recently during the rewrite. And it's not much about Linux because I guess many of you are Linux users and Linux developers, so you know how it works there. Okay. So let's start with some basics. Here I have just an overview of platform-specific defines you can use in CMake to distinguish platform-specific code. Each of the platform defines gets defined on the platform where you build your project. So there are defines like Apple, Win32, or Unix, which gets defined on each platform. With Unix, it can be tricky because Unix gets defined also on Apple. So in case you want to detect Linux, I use something like Unix and not Apple, for example. Then CMake also provides compiler defines if you want to distinguish, for example, between MinGW or Microsoft Visual Compiler. And I also include one tip for you because it's something that took me a while to figure out. When your application, for example, provides a QML plugin, this plugin has to be marked as a module, otherwise Qt on Windows won't be able to load it. That's a Windows-specific thing. It's mentioned in the documentation, but I didn't see it before, so I'm mentioning it here. So it might, because I think it might be useful for someone. And just to complete the topic, there are also Qt defines similar to CMake support I mentioned before. These are on the source code level and not on the build system level. So you can use these to distinguish your platform like Mac, Linux, or Windows. And same goes for all compilers. Okay, so now let's start with our first platform, and that will be Windows. So what everything you have to do for Windows? First of all, you might need to include a manifest file. The manifest file is in form of XML file and lets you define specific needs for your application. For example, in case of Fedora Media Writer, we use this to get some additional privileges because, as I mentioned, it writes the Fedora images to USB drives. So for that, we need special permission. But you can also, using that, you can also define another stuff like that your application is DPI aware or compatibility with other Windows versions and things like that. Then you probably want to create an installer for your users because probably you don't want your users to build your application themselves. And on Windows, the only way you can do that is to create an installer for them. And then you want to sign the installer. Otherwise, when users try to install your application, they will get warning it comes from unverified source. So therefore, we have to sign them. Okay, let's start with the first step, how to get Qt on Windows. So there are more options. You can get Qt from the official Qt installer. You can download it on the official Qt web page. Or the advantage of Windows is that you can cross-compile Windows application on Linux. So you can use min-gw packages. And that can also make your life simple, as you can do it from one place. And in case you want some automated builds on GitHub, you can use this. You can include this action, which allows you to specify a Qt version you can use and the compiler you will use to build your Qt application. We use this to provide automated Windows build on GitHub. Okay, so let's start with the manifest file. So here I have example how to include the manifest file with your application. In CMake, you just use target sources, your target name, and path to RC file. The RC file might look like this one, where you specify the path or the name of the manifest file, which will get included into your binary, and then icon for your Windows application. And I think this works only for min-gw compiler. With the Microsoft Visual Studio compiler, if the Windows manifest matches the application or the target name, I think it includes it automatically. But I haven't tried that because we use the min-g compiler, min-gw compiler. And just to show you how the manifest file look like, this is the one we use in Fedora Media Writer. You can see we just require additional privileges for the write access. And when we are talking about CMake, one more tip for you. This is a specific thing to Windows. When building your Windows application, you have to specify its Win32 application. Otherwise, when you build it and start your application, it will automatically open the Windows terminal. And that's probably also something you don't want for your users to experience. So there are two ways, either in add executable command, you specify its Win32 application, or you can use set target properties on your target and set these properties to true. There are two ways. Now, when we build the application, we want to start preparing files for the installer. On Windows, you basically have to bundle or include all the libraries which are not present on the standard window installation. So that might include Qt plugins, QML modules, or some system libraries. If you do this manually, you can, but you in some cases, for example, in case of QML modules and Qt plugins, you have to make sure they will keep their directory hierarchy. Otherwise, Qt won't load them, and Qt libraries and system libraries can go to the root directory. But if you don't want to do that manually, which probably that's something you probably don't want because it's a painful process. We do that for some builds, but in GitHub we use this way. You can use WinDeploy Qt. That's a tool Qt provides. When you run this tool, you specify QML directory and your application binary, and this will automatically install all your Qt plugins or all Qt libraries, and thanks to QML import scanner, it will also include all QML modules you need to bundle with your application. And system libraries still might need to be copied manually because I think WinDeploy Qt is only about Qt stuff. So some things still have to be done manually. Okay, now we have all the files ready. So you probably want to start creating your installer. To create the Windows installer, we use ANSYS. It's an open source system to create Windows installer. It's a script based, and it allows you to define everything you need for the installer, like files which get installed and uninstalled. You can define there the application name, version, link, things that gets into Windows register or the shortcut to the application. I don't have example how the script looked like because the one we have in Fedora Media Writer is quite long. But I think with this thing, it's something you probably copy from some other project and just modify it to your needs. So probably there is no reason to write this from scratch. And when you have when you wrote the script for the installer, you can try to generate it. To do so, you use make ANSYS tool. You can again get it from MingGW packages on Linux, or you can use Chocolate on Windows. Chocolate is a package manager from Windows. So you can, if you have it, you can just run a choco install make ANSYS, and you are done. Once you create the installer for Windows, now it's time to sign the installer. To sign the installer, we use OSSL sign code. This is again from MingGW package. On Windows, there is sign tool, or basically a similar tool to this. The parameters or the command is very similar. So here I have example of the OSSL sign code we use in case of Fedora Media Writer. With the sign tool, it's similar. You specify the certificate, password to the certificate. You need the timestamp, and then you specify path to the installer. Okay. And now, when you are done with the installer, it's time to try it. I don't think you will manage to successfully create the installer on the first try. I failed many times because many times you will find a library is missing, or I don't know, installer does something wrong. So this is like a try and repeat process many times. But if you once you've managed to do it successfully one time, there's probably no reason why it shouldn't work in the future unless you add some new dependencies. There's probably no reason why it should break. Okay, now it's time for another platform, and it is macOS. With macOS, the situation is similar, but in some ways it's more complicated. The signing is more complex than on Windows, and the main disadvantage is that you have to do all of this on macOS platform. There is no cross-compiling from Linux. So you need some Mac machine, or probably install macOS to virtual machine at least. So on macOS, it's all about creating application bundle. Mac doesn't use installers. You can think of it as app image, where you ship your application together with all libraries, which are not available on standard Mac OS installation. Steps to create the bundle are following. You need to write info plist file, which I will describe later. Then you have to bundle all libraries, since this is similar to Windows. And after you bundle everything, you need to sign the binaries. You need to sign the bundle itself. Then you create a Dmg file. And then Mac has an additional step. You have to send your bundle for notarization. I will describe all the steps more closely in next slides. So again, first step, how you can get Qt on macOS. What we use is Homebrew. That's similar to Chocolate on Windows. It's a package installer. So in our case, we just call brew install Qt 5 and brew install CMake, and it will give us everything we need. Another option is to again use the official installer from Qt. Okay, now we can start creating macOS bundle. So we start the process from CMake. With CMake, you define that your executable will be a macOS bundle, and you additionally can set icon to your application that you can see on the first line. Then we can specify some properties like the name of the bundle. Then you specify path to info plist, and then you specify macOS deployment target. And you also can specify where the application icon can go, because the macOS bundles has some directory hierarchy. So things like icons or additional resources goes into resources folder. So now, what is the information property list? There's a file you have to include for every application bundle. It basically identifies your bundle. You can set there your application name, your version, icon. You can use your own template. It doesn't need to be the one that is provided by default by CMake. The format is XML. Here I have a small example. You can see it's key value based. So specify, for example, the icon file, and then the variable gets substituted from CMake defines. So you can, as I mentioned, you can either use your own file where you have your own application specific defines. That's something we use in Fedora Media Writer. For example, for the version, we have Fedora Media Writer version, which gets substituted across the project. But you can use the one provided by CMake, but you have to know all the variables you have to define in order to properly get them substituted in the info plist file. Okay, now at this phase, we only have files or binaries which were built by our application. But as I mentioned, similar to Windows, you have to include all the libraries which are not present on standard Mac installation. So in this case, we use Macdeploy Qt. That is similar to WinDeploy Qt. It does basically the same. Here I have example of how I use it with CMake. So you can see we first search for it, and then we create a custom command that calls the Macdeploy Qt, providing path to our application bundle, path to our QML directory, and application executable. Because on Mac, it's not very easy to bundle all libraries manually, like on Windows. Because if you for example see this example, when I call OTool on Qt GUI library, you can see the path to the library points somewhere to the system. And if you just blindly copy this library to your application bundle, it will keep pointing to the same path. And when you then distribute this to the users, they won't be able to load it because the path or the library on that path won't exist. So if there are situations where you have to do this manually, you have to change the path to the library. You first copy it to the specified directory in the application bundle. In this case, it's the name of the bundle, contents, and frameworks. And then you have to call install name tool. That's a tool that allows you to change the path to the library. And if you doing this manually for all the libraries is probably not something you want to do. So Macdeploy Qt will do all of that for you automatically. But there are some situations where some libraries might be skipped. We have this situation with Fedora Media Writer where some library is considered as a system library and therefore is not copied with Macdeploy Qt. So we have to do this process manually. Okay, now coming to signing binaries. With Mac, as I mentioned, there are two things. You have to sign all binaries in the bundle. That has to be every library in the frameworks directory, and then it has to be your application binaries or the executables. These all have to be signed, and then you also have to sign the bundle itself. To sign your application, you can use a code sign tool. Here's an example how it can be run, or it can be done using Macdeploy Qt with code sign option. Then when you sign your application bundle and all the binaries, you have to create a Dmg file. Dmg file is a container for apps on macOS. As I mentioned before, you can think of it as an app image. To create one, you can use Macdeploy Qt again with the Dmg option, or you can use a GIUtil. The example is here. So we call a GIUtil create and specify the application bundle name, the output, and some other parameters. And then the next step is notarization. This is specific to macOS because on Windows you just sign the installer and that's it. Apple has additional step, that's notarization. The notarization process checks for any malicious code or components and also verifies whether you signed everything correctly. This is done on Apple servers, so you send them your application bundle. they will then reply you, they will send you an email back with the result. Once again, you can use make-deploy Qt to send your application to notarization, or you can use xrun auto notarize app, then again specifying some parameters. Once the notarization is complete, you will receive back an email. The notarization produces a ticket that tells that your app is successfully notarized. Then you have to include this ticket within your application. So your distributed application is identified as notarized. Next time anyone wants to try to use it. And to include the ticket in the bundle, you just run xrun stepper, the application name or the name of the bundle. It includes the ticket. And then you again create the Dmg file, which you can finally distribute to your users. At this point, your application is properly signed, notarized, and you are done. Again, similar to Windows, that's probably something you won't make on first try. So again, this is try and repeat step many times. But again, once you do it one time and it works, and you know you have a way how to automate it, it's probably there is no reason when it should break until you introduce some new dependencies or anything like that. Okay, and that's it. Now it's time for some questions. Okay, I can see some questions in shared notes.
Yeah, also there are some questions in the shared notes. I'm not sure if you want me to read them for you, if you can
I can read them, I see them.
Okay, great.
First question, someone asking, I wrote the Qt application with Kirigami and K18n. While I'm struggling to varying extent to create builds for non-Linux platforms, I'm struggling the hardest to create a build for iOS. I know it's possible to do since Subsurface was ported to run there, but I cannot find any documentation on how to do it. What steps could one take to create this build? Okay, I saw this question before my talk. Honestly, I don't have any experience with iOS, but I would expect the build process or the bundling might be similar. So you probably have to bundle everything with your application. But as far as I know on iOS, the only way how to distribute your application is through the App Store. So I have no experience how to get your application to App Store. Okay, second question. Where did you obtain the certificate for signing on Windows? I myself don't have a certificate for Windows or even for macOS. That's something our Fedora engineering does, the signing process. So they have the certificates, so they do the signing. Also, the packages are built in Qt, at least for the Windows build or the Windows installer. The package is built in Fedora infrastructure and just gets signed with the script we provide. Third question. How robust would you consider using Cheetw for cross-compiling Windows versions from Linux compared to compiling natively from Windows? So I think for Qt, at least regarding Qt stuff, if you don't have some specific libraries, I would say it's robust enough. I think it has everything you need, all the tools. I haven't tried to actually build Fedora Media Writer natively on Windows. We built it natively in GitHub CI, but there we also use MinGW. So I haven't hit any issue with MinGW or anything I would like or I would be missing. At least for our usage. Another question: do you think you could run VSL to VSL to run the tools instead of MinG on Windows? I honestly don't know what VSL is. So yes, I think as I mentioned, for example, for the signing, there are alternatives. There was a talk on Thursday, similar talk to this one, just they didn't go that deep. They use the sign tool, for example, for Windows signing. They didn't use the MinG version. So yeah, all of this can be done using native Windows tools. Have you tried, another question, have you tried uploading your app to the Apple and Windows app stores? I have not. The only official way how we now provide a Fedora Media Writer is through the getfedora.org webpage. I once checked how to get your application on Windows Store. I don't think the process is easy because I saw that there were many steps in order to get their application there, and that's probably not worth the time. So at least in this case of Fedora Media Writer, I think the way how we provided the discoverability on the getfedora.org page is enough for our use case. Oh, I think I'm got the fourth question wrong. The Windows subsystem for Linux. That's the running Linux on Windows. Yeah, that's probably something that can be run instead of MinGW. But I haven't tried yet.
Right. Given that there is still some time left, maybe we can wait a few more minutes if someone else has questions. If you have, please add them in the shared notes.
If you decide to build your application on Windows and Mac, I think you can check how we do that in Fedora Media Writer. All the examples I mentioned here are from there, so you can see how we do it. You can see how we build it in GitHub CI, for example. That can be also helpful. We built in Fedora in GitHub CI. We built only unsigned binaries, the signed the signing, as I said, is done by Fedora engineering. But you can even there you can see the scripts we use for signing. So you can check it there and get some examples. Yeah, there's another question. Have you seen the talk done by Dan and Ariane on Friday? Yeah, I saw it. I mentioned it during when answering one of the questions. Yeah, it was a great talk. They also built they also use GitHub CI to produce builds. It was, for me, it was interesting to learn how to do the signing there and keep the certificates in private. That was a useful thing to know. Still, the signing, because it's done by Fedora engineering, I probably won't have access to certificates, but it might be useful in future if we decide to somehow automate the builds and the signing. Because right now I have to open ticket for them and ask them to do the signing, to sign the builds I produced.